right, I'm going to do this in English because I know there are some English speakers and I wrote it in English. So we'll see how that goes. So yeah, this is about navigating the shared responsibility model and avoiding pitfalls along the way. So let's see if we can get this to work as well. Is there a mouse pointer? Here we go. Maybe not here. Right, so who am I? I'm Fredrik Ragnarsson, also called MrPekka in this community. I am the CTO at Evolate, which is a AWS consultancy company. I have a background in a lot of system administration and have more and more moved towards security and cloud computing. So what is shared responsibility and the shared responsibility model? It wouldn't be a talk in 2023 if there's no ChatGPT involved. So I asked ChatGPT, and this is what it spat out. So shared responsibility is a key concept in cloud computing where both the cloud service provider, CSP, and the cloud customers are responsible for different aspects of security and compliance. So if you ask Amazon, this is the image that they will give you. Basically, AWS. I'm going to speak mostly about AWS because that's the area I know most about, but this is applicable to almost all public clouds. So AWS, they say that they are responsible of this for the security of the cloud itself, and the customer is responsible for the security in the cloud. So they manage things like data centers, the different regions that they have, power, environmental factors for the data centers, physical access for data centers, also their internal networking, routing, firewalling for their own services that they provide, and also the software and OS for their managed services. So they run a mix of operating systems and hardwares and softwares. They manage all of that. But you as a customer, you need to manage your client-side data, your own encryption. You need to manage your own operating systems if you run in EC2, for example, virtual machines. And of course, your own firewall and network configuration. And importantly, your own data. That's your responsibility, of course. So who is responsible for what? As a little example, I'm going to talk about a service called EKS, which is Amazon's managed Kubernetes service. And specifically EKS running on Fargate. So Fargate is a serverless service that they offer where you can run containerized workloads serverless. There's of course always a server somewhere, but you don't manage it at all. So in this case, Amazon managed the control plane of Kubernetes, so the scheduler and things like that. They also manage then the operating system, underlying operating system that actually runs your containers. You manage your own data, the pods and containers, any cluster add-ons that you install, the cluster configuration itself, the networking, the VPC, security groups in Amazon, things like that, the role-based access control system in Kubernetes. So it's pretty simple. Basically, you manage the Kubernetes configuration side of things. They manage the control plane and the underlying OS. If we then move over to still running EKS, but in this case on EC2, which is their virtual machine service, it's almost exactly the same, but of course now you're running your container worker nodes as virtual machines. So now you are responsible for the operating system that runs the worker nodes. Amazon provides you with container server images called AMIs. So they pre-package a Linux operating system that automatically connects to your control plane and runs everything. And this is where a lot of discussions usually come up during PCI audits, for example, because this is a container image provided by Amazon. So it can be assumed in some cases that they are responsible for the security of it. And to a certain extent, of course they are. They have built it, and it's pretty well built. It has sane defaults. But in the end, it's your responsibility to make sure that it's patched and updated. You might need to harden it based on the different frameworks that you are under, and of course making sure that you patch it. And this is usually something that ends up with a lot of discussions, in my opinion, with different QSAs and auditors, just trying to make sure that everybody understands where their responsibility ends and begins with the CSP and the customer. But in the end, it's you as a customer who needs to inspect the AMI that Amazon provides. You need to make sure that you harden it to your specifications and that you keep it patched and updated. Yeah, this is an area that can be tricky sometimes. If we take a look at IAM, which is the Identity and Access Management service in AWS, it's the service that manages user roles and policies. The service itself is managed by Amazon, but you, of course, are responsible for configuring the different policies and roles, attaching them, and so forth. But here, there is an interesting thing that can happen. So there are customer-managed roles that you create yourself, but there are also policies and roles that Amazon provides for you, pre-configured. So there are read-only roles and admin roles and a bunch. It's hundreds of roles that they have built that you can use. So you might find one that gives you access to an S3 bucket or database, something like that, and you feel this is a good policy, I'm going to attach this to a user. Everything is fine and dandy, but the problem is this is managed by Amazon, so they can, without notifying you, make changes to this Amazon managed role that you just attached to an IAM user. And you might not get informed about it. So all of a sudden, an IAM user has access to something that you didn't know because they changed it in the background. And they don't really provide a good way of getting updates on this. There are some third-party mailing lists that you can subscribe to that will basically give you a diff for all the Amazon-managed roles if they change stuff. So this can be a very dangerous thing if you assign access that you believe is the way you assigned it, and then they update it in the background. And it can be hard to say exactly where the responsibility here lies. So a good way, of course, to solve this is either by monitoring these lists, or you can also set up like a Lambda that goes through your roles and do the diff yourself. But most easily, you can just take the policy, copy it, and create your own role that is just a copy of it, because then you know you are the one responsible for it. You will do the updating. And then you can take a look at the ones that Amazon provide and see if they make any changes. Then you might want to put that in your role. Then we have another example, which is AWS Outpost. So this is a service that they provide where you basically order a complete rack or several racks of hardware that you can place in your own data center or at a remote site or whatever, which runs a local copy of the Amazon cloud, basically. So you can run EKS and S3 and RDS, all the different Amazon service, not all, but most of the common services locally in your own data center or at a remote office or something like that. So they will ship a huge rack, and you have to provide power, you have to provide the internet connection, and of course, here it's your responsibility to make sure that the temperature is not too high, the humidity is not too high. You are now responsible for physical access to the location where this exists. So this can also muddy the water a bit with responsibility, because in the public cloud, Amazon is of course responsible for all the data centers, all the physical access. You don't need to worry about this at all. But here, they are responsible for the actual running service that they provide. But you are responsible for the physical layer of it. And then you're also responsible for the top of the previous image as well. So like your own operating systems and configuration. So this muddies the water even more. So Outpost is an area where it's really, really hard to do audits sometimes. Then a little interesting example from Azure as well. As a AWS consultant, of course, I need to bash on Azure. That's just the way it is. So back in September of 2001, they had a little issue in a part of their infrastructure called OMI, which is the Open Management Infrastructure Agent. So when you run Linux servers in Azure and you enable certain features like log analytics, some other monitoring tools, they inject this agent without telling you. If you read up very carefully, you will find it in the documentation, but it's not obvious when you do it. So they basically inject this agent that will do some monitoring and logging and stuff in your container, in your operating system. This little thing, of course, did run as root. Maybe not great. It turned out it's vulnerable as well. So it was a security company called Wiz that found the issues here, and they called it Oh My God, which is a pretty good name. This is the CVE for it if you want to look it up. So basically what they found was that this little agent, it listens to a local Unix socket and also on some network ports, TLS ports. And it had 3 privilege escalation bugs in it and a remote code execution, which is not great. So the interesting thing is, how did you? What was the process for actually utilizing the remote code execution? Well, you craft a packet with the command, you send it to it, and you just remove the authentication header, the authorization header, and it just executes it straight as root. Not perfect, I would say. So in this case, it's super easy to exploit. It's an agent injected by the cloud service provider into your virtual machine that you are responsible for. So who's to blame here? It's a very hard situation because in the end, you need to monitor it. It could be someone else who hacked you another way, getting access to it. So you need to have the correct tools in place to be able to monitor and detect stuff happening, look at the processes, look at the opening ports, things like this. So in this case, it was an error on the side of the service provider, but it's still your responsibility to make sure that your server is correctly configured, patched, and detect things like this. And of course, if you read up on the documentation really, really, really carefully, you would have known that Azure actually injects this this little agent, and you could have taken a look at it. But it's really, really hard. And this is not just Azure that does this. Amazon does it too with SSM, and GCP does something similar, I believe, as well. So this is something to be aware of. So a short little recap here. Make sure that you understand where the CSP responsibility ends and your responsibility starts. Assume that you're responsible for basically everything, because it's very common that you assume the CSP is responsible for something, so you just leave that be, and then you have a breach, there's a investigation, and nobody took responsibility for a tiny part, and that got owned. So it's better to take responsibility for something that the CSP says that they also have responsibility over, and actually have overlapping responsibility, of course. And don't blindly trust the provider. As we saw, they can make mistakes. Everybody can make mistakes, but when they do it, make sure that you catch it before a bad guy do. And also make sure that you understand the services that you run. Make sure that you read the documentation, because the defaults might look sane, but depending on how you use the service, they might be insane. So make sure that you really understand the configuration of the services, because sometimes they need a lot of configuration to actually be safe in your environment. And of course, just patch all your stuff all the time, because it's a dangerous world out there. And yeah, that's it. I want to thank my good friend Enrico, who's a QSA, for some talks about this, and also Johan from Detectify. And that's it. And I would like to see if anybody has any questions or any stories of shared responsibility where you've had issues. Nothing? One over there. Yeah, just ask a question and I can repeat it.
So, I would just like your opinion on, do you see customers going and using, say, golden AMIs, where they build in all the tools they want? to use, or do you see them using standard AMIs like Bottle Rocket or something else, and then they add, say, permissions and everything that they need outside? Like, do you see any trends there in terms of open AMI versus standard AMIs?
Not really. So the question was basically if I can see any trends regarding how AMIs are packaged or used, if you're rolling your own or packaging pre-existing and things like that. I don't see any real trends right now regarding this. It's very much high and low, but my recommendation is, of course, even if you're using, for example, AMIs packaged by Amazon or a third party, to actually pull it down, inspect it, and then put it in your own repository, inject your own monitoring tools, do your own hardening, packages as a new AMI, and keep using that, because it's very dangerous to use an existing AMI if it updates or something happens to it. Yeah. Any other questions? Yes.
Yeah, so you talked about that Omigod exploit. So what would be the best way to catch it early? Would it be to have like some kind of audit logging or CM logging, or is something else?
All right. So the question was the oh my god vulnerability with the injected agent. What would be the best way to catch this? And it's hard to tell. I wouldn't say it's really not my area of expertise, but I would say making sure that you have some sort of monitoring on it to list processes that are started and are running, and also ports listening. Because if suddenly there pops up 3 TLS ports that are listening on your server, you should probably be aware that a random service running as root started listening on random ports. So that's probably the way to catch it. But of course, also my point about understanding the actual configuration. If you read up really thoroughly, you would have noticed that they talk about this agent being injected, but it's buried deep in the documentation, so it's very easy to miss. So do your due diligence when enabling new services, and really read up on the documentation and understand what actually pushing that enable button in the GUI actually does.
Thank you.
Yeah. And one question more?
Did this oh my god vulnerability, did that change any of the wording in the shared responsibility model from Azure?
Okay, so the question was if the oh my god vuln changed any of the wording or in the documentation regarding shared responsibility model. I'm not sure. Maybe. Probably. But I don't take my word on it.
So, like, can I follow up?
Yeah, sure.
So what is your view on it? Whose responsibility was it in this particular case?
All right, so the question was my opinion on who's responsible in that case. I would say that it's mostly on Azure because it's a software that they develop and push out. It was not very obvious that it happened. If they would have popped up a warning saying, hey, by enabling this, just be aware we will inject an agent into your server, that might have made people more aware of it. So I think Azure is to blame for a lot of it, but in the end, it's your responsibility as a customer to detect and prevent stuff like this from happening. So it was not a great look on Azure, but it's definitely, in my opinion, your responsibility to detect this. Yep.
Do you have any good ideas on how we can cooperate to create a more secure environment in clouds?
Right, so the question was if I have any suggestions for how we as a community can basically get better at this, right? So I think it's important to talk about it, and also nothing is really black and white. There are a lot of gray areas, and this is something that we need to talk about and discuss. And this is usually a discussion that you have with your QSA or auditor, and it's a lot of back and forth. And I think it's important to try to document things and share it with other people. So just having more talks like this and showing examples, real life examples where you have had disagreements around the shared responsibility. Yeah. Time for fika. All right, if there's no more questions, that's it.